Now, in the power of a product rule, we could see that, let me state this here. X times y raised to the a power equals x raised to a times x raised to a also. What it means is that this a, the reason why I used to submit the property, you can review the video if you want. A, this a, I'm just going to put this. Oh, oh. This a distributes x and distributes y. That's why we get the answer this problem. Now I'll give you an example. Hmm. Here's example. Now number one, I'm just going to make it clear. If xy raised to 2, that means that we're gonna distribute the power of 2 to x and y. So that means that x would become x squared and y would become y squared. So you could see what difference. Now what if x raised to third power y raised to 2? Since x has a degree of 3, we're going to multiply them both using the power of a power rule. You can review the video if you want. 3 times 2 is x raised to 6th power, and that y would become y squared. Next, what if this thing is what if this is x, well, actually x raised to third, we're going to use the same example, but y is 2 and this is 2 also. It's still the exact answer, so we're going to use this x raised to 6. Since y has a degree of 2, we're going to multiply it by 2. So this means that y raised to the 4th power. Now, what if it has a fractional exponent? So let's assume that x raised to 1/3 while y to the second raised to the third power. We're going to do the power of a power rule. So 1/3 times 3. We're going to cancel 3. That means that we only left just x. And y, since he has a raised about 2, 2 times 3 is y to the 6th power. Now, what if the numerator has greater than 1? So this is just x, and then you're just gonna put y, and then you're gonna put 2/3. Y raised to the 2/3 power raised to 2. We're gonna distribute x. We're gonna distribute 2 from 2x, so x squared. We're gonna distribute 2 to y raised to 2/3. So 2 times 2 is y 4. The denominator is not affected, so here is your final answer. You could pause the video if you want. Now, what if xy raised to, I'm just gonna add second power. Okay. So in order, if it has a variable that has greater than coefficient 3, you need to multiply it too. So x raised to the second power, I'm gonna distribute 3a to x second. So that means that this 2 times 3 is 6, so we're gonna left with 8. And y times 3 to the 3 raised to, and 3a distributes y equals y to the third a. So now the second part is, what if there's a different variable or the same? Or actually a different variable and the same. Okay. Example, if x raised to 2a and y, that means raised to the third a, it will be the same, but 2 times 3 will be 6, and a times a is a squared. Yep, and this thing would be the same, so uh, I hate this. Okay, now what if it's a different variable? So x raised to 2b y equals raised to the third 3 to the a power again. That means that a, we're gonna put x, 3 times 2 would be 6, and a times b would be just a b. It can be interchangeable if you want, but make it formal, and then you're just gonna put y to the third. Actually, just gonna put it. It states here that x divided by y raised to a equals x raised to a divided by y raised to. Actually, it's still the same thing. You just need to distribute. This time, a is distributed to the numerator and the denominator. I'm just gonna write it just in case. Just gonna put this is a and this is. That's why we did this answer. Okay. Now I'll give you an example. So just assume. Now if x over y raised to the second power, it distributes. So 2 distributes x, so that becomes x to the second power, and 2 distributes y, so y raised to the second power. Now what if it has its own exponent? So x raised to the second power divided by y. Um, since x has a degree of 2, so distribute 2 to 2, that means that x equals raised to the 4th power divided by y raised to the second power. Now what if this is a variable? Like, since x has a variable b, so this will be distribute. So 3 times b is x raised to 3b. Actually, the first would be 3, then b, because that's how the coefficients first, then a variable. So divided by y, this, so this 3 distributes y, which is 3. Now, what if this variable has a coefficient 2? So let's assume that this would almost be the same, except um, since since the coefficient of b has 2, so that means 3 times 2 is 6, and then b over still the same thing. Okay, so I'm gonna bring back the power of a product rule. So if um, 2xy raised to 2, this means you're gonna distribute the constant, the variable, and y. So this means the answer for this is 2. Gonna distribute 2 to 2. So actually in I don't know, some, so 2 to raised to the 2 power is 4, and then x raised to 2 is x squared, and y, that would be y squared. So okay. So now I'm gonna erase this because this can be any actually this too can be anything. Can be 3, can be 4, can be 5, as long as it's raised to the 1 degree. All right. Now I'm just going to what if yes, because the x has a coefficient like 3 or 2, so we're gonna put 3x raised to third power. Everything is going to be distributed, so which is good here. So that means that this means that 3 raised to the third power is 27 x to the third power over y raised to the third power. You could possibly do if you want. It says in the zero exponent rule that whenever any variable, which is I'm gonna give you an example, which is a raised to the 0 power, it will always be 1. Actually, it's very easy. You could just memorize this. Or it can be b raised to the 0 power equals 1. X raised to the 0 will be 1. And then y raised to the 0 power would be 1. Actually, that's it. I don't need any example. Actually, in constant also, 2 raised to the 0 power will always be 1. And 3 raised to the 0 always be 1. And 4 always raised to the 0, always 0 is raised to 1. And then 5, 15 raised to 0 always be 1. Any higher number that has a degree of 0 will always be 1. So I'm gonna move on. Okay. In the negative exponent rule, it states that um, whenever a variable or a constant raised to a negative number like 1 or something like that, this will be equal to 1 over a. The reason why is very, very simple. I'm just going to make it in detail. Now, a negative 1 equals a negative 1 over 1. Now, to get to be positive, this would be is inverse. The inverse of an exponent of 1 is just 1. So in order to get here, you need to put this in the denominator. So, oh, actually, it has a, we're gonna put times 1 because that's always been times 1. So that means that this is equals 1 over a. Now I'm just gonna remove the uh, now I'm gonna give you an example. Um, 2 raised to the negative 1. That means that this would be, we're gonna put 1 in the numerator and the 2. Since there's no negative in the denominator, this is an answer 1 half. Next is, what if this is 2 to the negative third power? Well, that means that this is 1 over 2 third. That means that this is 1 8. What if it is a variable? Well, if it's 2 raised to negative a, this would become 1 over 2a. It's same as exponent, or you could just put it exponent. So if it's a raised to negative 1, this would become 1 over x. Still the same thing. Even even you put 3 or just a. Actually, I'm just gonna. It can be anything if you want. I'm just putting this because, well, it's very simple and plus it's not causing any trouble. Now, X is that. It's not that I can explain. I'm just going to erase everything. Also, if there's a fractional exponent like x raised to negative 1 half, the answer here is actually is 1 over x 1 half. Anything. Now, I forgot about something. What if 1 over 2 negative 3? What's the answer here? The answer here is very simple. 2/3. When the numerator has a negative exponent, it will be, you need to turn it to positive, so this is the answer. Actually, I forgot. When there's only applies if this is a negative exponent in the denominator. So just forgot about it. This includes like 1 over x raised to negative 3. This would be x to. Actually, you could do whatever you want here. Just in fractional exponent, it states here that the I'm just gonna write it here. Just it states here that the a root of x raised to b equals x raised to b over a. It means that I'm just gonna put a note that the numerator, I'm just gonna put an num over denominator The numerator is the raised power, raised to a power, while the denominator is the indice, which the indice is a. Just gonna put that as I'm just going to remove the entire thing and then let me give you an example. Let's just gonna put it here. Square root of x raised to the third power. It's third power. Now, of course, the square root of the indice is 2. So that means that if you change it to a fractional exponent, we're gonna put a x and then put a line in here, and then that means that 3 will be on the top and 2 will be on the bottom. So that is number 1. Now in number 2, what if the raised power of the x is a fraction? So I'm just gonna put here. Let's put another square root and then we put x raised to 1/4. Now that means that we're gonna put x and then we're gonna put 1/4 over 2. This can be simplified through reciprocal. The reciprocal of 2 is 1/2, so 1/2. So we're just gonna put it here. So that is your answer here. Now, what if the indice itself is a fractional? So I'm just going to put 1/3 square root of x raised to the second. Now that means that x 2 over 1/3. Now the reciprocal of this is just gonna put 2. Oh, wait, I'm just gonna put 2. The reciprocal of 1/3 is 3. That means that x is equals 6. Okay, now I'm gonna give you even more example. Now, what if the indice itself is a fractional, while the raised power is also a fractional? So I'm just gonna put here 1/3 square root of x of 1/3. This means that this would be x, and then this would be 1/3 over 1/3. Now, of course, if you this is a reciprocal, so that means that I'm just gonna put here. This would be cancelled out. That means that x is just the answer, or this is one. Oh, you could actually x over 1 is equals x, so you could do whatever you want here. Now, what if this thing is a constant in a root? So let me just put here. Now, what if this is square root of 2? Well, square root of 2, if you put it in the fractional exponent, since a constant has a degree of 1 always under the rules, so that means that 2, we're gonna put our line. This means this is 1. This is also its degree of 2 is 1, and this is 2. That means that the answer is 2 raised to 1/2 answers. Now, what if this is a one third? Let's assume. Or what if this is greater than one? If this is like if we want to turn it to a fractional, this is the answer is 2 3 over 2 is the answer here. Now, what if this is a fractional, like square root of 2 over 1 over 4 power? This means that this would be 2 raised to 1 fourth. Now, you need to simplify this, so over 2. If you convert this to 1 over 4 times 1 half equals 2 raised to 1 8 1/8, and now that is your answer over here. Now let me erase this a little bit. Now what if the root itself is a fraction? Now of course that will mean example like 1/8 square root of 2, just 2. So that means that if you convert, actually the easiest way to identify this is very simple. If the degree is 2, that would be you gotta put 2 and then the answer here is 1/8. Now this is the fastest way to solve this. Here is very simple, just put here. And then also you could, the fastest way to, if the indice itself is a fractional, you could just put 2 and then put the 1/8 here. That would be your final answer. Unless this is just its degree is just 1. I'm just going to, hello, I forgot about something, so I'm just going to do this. So what if the indice and the raised power have a fractional exponent, so on a constant, because I already do the variable. So if I put 1/8 square root 1/8 of root of 2 raised to 1/8, the answer here is very simple. The fastest way you could do it is when you see both indice and the raised power have the same thing, just cancel it all out, and the answer is just 2. That is your answer here. I'm just going to get the end scene. So I hope you enjoyed the video. In this video, I decided to complete this so that this would be part 2 of this video. So I hope you enjoy and see you in the next video. Thank you very much.